We are the product drying team for CCJ Snacks. Our goal is to extend product shelf life using new forms of desiccants. And my name is Jack Faskowicz.
My name is Jack Tunney.
My name is Joey Imperial.
My name is Krista Kim.
My name is Yu Kai. Oh, sorry.
And I'm Wayne Yo.
All right, so to kick it off, we'll go over the background and the objectives of the experiment. So for some of the background, our sponsor is having an issue with their desiccant not maintaining its shelf life promise of 12 months. It's getting only like 3 to 4 months. They're also looking for a way to automate the process of depositing desiccants into the packages to reduce the manual labor time. So with that in mind, our project objectives is to research for an appropriate desiccant that would keep the product from being chewy throughout the entire 1 year shelf life. And then propose a solution that would automate or semi-automate the process of desiccant placement into the product. Now we used a technical approach. So we performed desiccant efficacy experiments under extreme environmental conditions and comparing against current oxygen absorbers. So we designed the experiment, performed accelerated experiments, and then performed a cost analysis.
For our research, we looked at 3 different types of desiccants that can be used within the CCJ Snacks packaging. The first was the current desiccant being used. It's an oxygen absorbing desiccant. It's in the snack packages, they are sealed and therefore limiting the amount of oxygen and moisture that can be absorbed. So we are not sure if this is the best option, but we also looked into bentonite clay desiccants, which are cost effective and typically have no absorption issues unless under extreme temperatures. And then lastly, we also looked at silica gel desiccants, which are FDA approved, and they seem like a great option as well, but they do also contain chemicals inside the desiccant package, so they may have some harmful chemicals that may contaminate the food.
So moving on to the experiment, we carried out the experiments in VWR ovens set at around 60 degrees Celsius to accelerate the aging process of the dehydrated fruit chips. This is done so that we can try to simulate the high temperature storage of the fruit chips. We had 5 different sets of experiments. The first one with control containing no desiccant, one with the original oxygen absorber, one with an oxygen absorber from a different company, and then 2 separate silica gels from different brands. Once the chips were removed from oven, we performed 3-point bend test, and then from each set, we collected 10 data points, and then we plotted it against a stress strain curve, and then we compared the data accordingly. The desiccants that were used with the most brittle fruit chips will be deemed the best desiccant and proposed to the sponsor as a solution to their problem.
So the results that we got from this experiment were that ultimately the silica gel desiccant was the best option. And this particularly from the company Mid-South. From all the different desiccants we tested throughout the period, this is the found result that had the best crunchiness for the chips, which is the actual result that CCJ's was looking to get. Unfortunately, more tests are needed to be run in order to get a clear result due to having some setbacks with time and not being able to run this experiment for a longer period of time in the oven to get more accurate results.
So with the results in hand, it is recommended that our sponsor switch to the using the silica gel desiccants from Mid-South packaging. However, it is also recommended that this experiment to be run again, since many variables need to be accounted for, such as testing all the packages with either the seal broken or intact. The team also recommends for the future performing the aging process in an oven that contains moisture, so the aging of the product can be exactly replicated. For example, the packages can experience humidity while in transport or during their shelf life. Also concerning the automation of desiccant insertion, it is recommended that it is something that should be revisited due to the small scale of the current business, and the time it was saved is not worth the price.
So when moving towards future work, our team came up with a few ideas that we would change or do differently if this project was continued with in the future. Firstly, the oven that we used to test the desiccant didn't necessarily contain moisture. Therefore, it wasn't an exact replicate of the aging of the product. So we would recommend finding a environment which actually replicates this aging process. Secondly, bentonite clay desiccants were unfortunately not delivered to us due to a mix-up from the company. Our team would recommend testing these in the future, as from our research, they seem to provide the best results for containing and extending the shelf life. And finally, due to shipping complications, the products were not received until late into the project, meaning that we were only able to keep them in the oven for a week. We recommend at least 2 weeks in the oven would be preferred to correctly emulate the full life, shelf life of the product, of which is 12 months.